Okay, so my name's Eric. I work at Ada, and this evening I'm going to talk about analytics at Ada, our journey to ClickHouse. So a little about me. I'm a staff engineer at Ada. I work on the developer productivity team. So we're interested in helping engineers ship with more velocity and fewer defects. And I've been there for about 4 years. I've got a background in runtime systems, and I'm based in PEI, Canada, on the East Coast, a small province. It's lovely. And at Ada, I generally am working on analytics or our runtime retrieval systems. So think about RAG systems. So Ada, for those of you who don't know what Ada is, we're a company that builds AI customer support agents. We deploy these to the web. We support voice, email, custom channels via our platform API. We're Toronto-based, and we're globally remote. So we're founded in 2016 by Mike Murchison and David Harari. And to date, we've automated over 400 million conversations. And you'd say, well, okay, why do you need analytics? Well, we use analytics to help our customers understand how their agents respond to their customers. So they configure their agents on our platform. We're a multi-tenant application. And they rely quite heavily on our analytics to understand how the agents are performing, how they can improve their training, look for knowledge gaps, and measure improvements. So some of our notable logos you might be familiar with, you've got Square and Pinterest, AirAsia is a big one, Canva, and more recently the New York Times. So our stack. It's a Python backend. We're using a monorepo. We deploy a monolith. We use MongoDB as our operational DB. RabbitMQ for asynchronous processing, and we deploy to Kubernetes clusters around the world. So this is our journey towards ClickHouse. So I kind of want to throw it out to you for a second, get a show of hands of, if you've worked on a piece of technology that you've deployed that eventually hasn't scaled well enough. It may be too complicated. It may be inefficient. And maybe you've had to retool things or rethink your implementation. Yeah, most hands come up. Scaling problems are good. We can't necessarily over-engineer every problem. So this is a little story about some of their choices along the way at Ada and how we've overcome them and how we got to where we are today. So a little history of analytics at Ada. In 2016, our startup was founded, and we were using MongoDB then as our operational DB, and it was powering basic analytics. So we had a simple service that would run pipeline aggregations on a schedule and email these reports out. This is how analytics was for a lot of customers. Eventually, we hired internal data analysts who wanted to be able to help make business decisions, and they said, well, we can't write Mongo queries. We need SQL. So, that led to us implementing Redshift in 2018. And to get the data from MongoDB into Redshift, we set up Airflow clusters. At that point, we decided, we've got this great data warehouse. Let's power in-app reporting as well with this, right? One database to rule them all. That's sort of the holy grail of data engineering. And so we went ahead and started to architect some reports into the main application. And we've got Airflow DAGs to fetch changes from MongoDB, write these to Redshift tables, et cetera. So around 2019, we started to have more requests for more reporting in our application. And we started to hit some walls with Redshift, very clear concurrency issues. And try as we might to scale up the cluster, we still had serious latency issues. We're not talking real time here. We're just talking, within 30 seconds maybe, something reasonable. So we added some custom layers on top of our application to make reports asynchronous with a cache layer and socket notifications, but really couldn't speed things up. Our queries from our report backend have very high cardinality. Very few of the queries are similar, so they don't really do well with caching necessarily. Anyway, onward and upward. 2021 rolls around, and we bring Elasticsearch onto the table here. We'd already been using Elastic for searching a conversation view. You can imagine our customers want to be able to search on what people are talking about. Perfect use case for that. 2021, we started to apply it to analytics as well. And kudos to Elastic. It's actually quite good at analytics. There's some problems, no joins, and again, our BI people are not going to write JSON syntax queries. They're not hopping into Kibana, and that's a problem. The bigger problem, though, perhaps, is that we've now got, we've got MongoDB, you've got Redshift, you've got Elasticsearch, we've got this glue here of Airflow moving data between systems, and 2022 we add another database, DynamoDB, for another use case, and by 2023 we're fighting a lot of data inconsistencies, support tickets, difficult to triage issues for any of our engineers, let alone new engineers. Real-time reporting's nowhere near in sight as we're dealing with high latency and serious bottlenecks in that pipeline. So 2024 comes around and we're like, okay, maybe there's another thing we can throw at this to solve it, right? So data inconsistencies, syncing from a MongoDB, using an updated timestamp index. Well, let's use Kafka and CDC and Debezium. Okay, that's cool. But it's got its own challenges. It's a whole other stack to build on, to observe. And as we witnessed on MSK serverless, couldn't meet our scale. So we just kind of had to revert back to the old style Airflow ES pipelines in a lot of cases. By the time we hit 2025, it was time for something new. Co-founder gets involved. There's some serious problems with analytics. This is what it's looking like, 3D pipes. There's a lot of pieces moving. It's difficult for anyone to explain, to jump in. I can't show a real graph of the topology here, but it's complicated. And it's kind of what it felt like. So some of those problems, like I mentioned, there's many sources of truth. We've got MongoDB, that's cool, that's fine. We've got Redshift, Elasticsearch, DynamoDB. Within these many indexes, potentially different clusters. In theory, it works. If you're familiar with the system on paper, it looks good, but in practice, there are always going to be failures, and the failure modes are many. Implementing Kafka on top of this sadly didn't solve our problems for us. The inconsistencies were eroding customer trust, and we're leading to even scaling issues with MongoDB maintaining those indexes I mentioned. So like I said, I work on the developer productivity team. And here's one little anecdote here. We had an engineer from another team try and build out a new report using this stack. And it took them over 2 weeks to publish some data, make sure it was copied to the necessary data stores, and make it queryable in our reporting system. And to some of you that may seem like, yeah, that sounds about right. Well, they're a very good engineer, and that's not the kind of velocity we want to be working at. That's okay, but given the data inconsistencies and the complexity involved, I don't think it was satisfying. So, a question we asked ourselves earlier, at the beginning of the year is, what if we could have a single analytics database that was quick enough to power customer-facing analytics, that could still power internal BI requirements, was SQL-based, had a scalable engine, runs locally, because that's absolutely critical to developer experience and productivity. And we ended up at this great database, ClickHouse, which is our fine sponsor this evening. So some of our key learnings. It wasn't enough to think about our, we don't have enough time to give you all the context here of how our system's built, but it was important for us to rethink how we were moving data, how we were writing data to MongoDB and what data we were trying to run analytics on. Our original design of using essentially CDC, or collecting all updates for MongoDB, didn't scale. We were trying to copy objects from MongoDB and update single rows in Redshift. Okay? That doesn't scale well, right? Updates at scale do not scale well. Not with our architecture anyways, at the scale we're operating at. So it ended up leading to a lot of complicated pipelines to deal with race conditions, managing state. We weren't necessarily using the tools that we might have been using to manage distributed state. There are other solutions out there, but they weren't on the table for us. So the CDC was also a problem where data in Mongo was visible downstream. So small changes could break across domains. And so we kind of rethought how we were doing things, and we arrived at something much simpler, where we were only publishing. So rather than relying on changes from MongoDB, we would publish events from our backend. So this is nothing new, but to us it's a different approach. So we would publish valuable business events, and that keeps the scale much more manageable for us. Trying to keep up with database I/O level updates at scale, rippling across your analytics infrastructure, wasn't going to work for this. And the other key learning for us was to power our reporting with append-only logs. All right, so that was something quite different, and it's very valuable. It's very valuable for everyone involved to have those logs of events. So our new architecture is quite simple. Like I said, we emit events from our API monolith. We batch those using RabbitMQ consumers, and we do batch inserts into ClickHouse tables. Again, we're using append-only logs, so no updates, table per event type. And now the last note there, within a single PR, in our API monolith, where all our important code lives, we can have a single PR to define a table schema, to emit an event, to insert a row, and to query the table. And that could be done in less than a day now. So a huge difference, a huge boost for developer productivity at Ada, and it has a lot of people very excited about the prospects. So, future work. We are planning we're not live with ClickHouse yet, so food for thought there. We are planning to go live within the next 2 weeks, hopefully, if things go well. We'll be load testing on Tuesday. So we have more work to do, emitting more events to achieve report parity with Elasticsearch. We are running shadow queries in the back end, so we'll replicate queries to Elasticsearch, to ClickHouse, and publish these metrics to Datadog, which we use for observability and make comparisons. We'll be doing backfills on those. We're using ClickPipes, which have been working quite well for us. Yeah, we'll be extending this work to our internal events as well, internal analytics. We've got a project planned to use the new full text search functionality here soon. And we're really interested in applying semantic search as well to transcripts. So if you're interested in learning more about Ada, here's a QR code. It's to our careers page. We are hiring. We're hiring engineers at all levels, DevOps, engineering managers, product managers, and designers. I'll be around for the evening if you want to chat more. There's some other, my colleagues here at Ada, we've got the black t-shirts on. Feel free to chat with us, and thank you.